So for this part of the lecture today, we'll be talking about sigma notation. Okay. And I would like to introduce this because we'll be using this a lot. Okay. So what is this sigma notation? So remember when you were studying mathematics during your early age, you were taught how to add numbers like this, 3 plus 8. Or maybe you have negative 2 plus 4. Okay. Or maybe you have 3 plus negative 1. Of course, this guy here, you can actually write this as 3 minus 1. Okay. But I'm just going to write it as is, 3 plus negative 1. So you were adding two numbers. Maybe you can extend it to three numbers, 2 plus 3 plus negative 1, or maybe four numbers, 2 plus 3 plus negative 1 plus 5, or even more, 2 plus 3 plus negative 1 plus 5 plus 8 plus negative 3 plus 2. Okay? Of course, if you have more numbers to add, okay, then this expression here will become longer and longer. Okay? So mathematicians have devised a way to shorten the way of writing this addition. Okay? So if n is a positive number, okay, actually it should be a positive integer, and we have x1, x2 until xn. So because we have this numbering here, we have the subscript 1, 2, up to n. So we expect that n is an integer. Okay. So if we have x1, x2, and xn are given numbers, then we will define this symbol here. So this symbol here, okay, to be x1 plus x2 plus x3 until plus xn. So this guy here, we call this the sigma notation. This symbol here is the Greek letter sigma, capital letter. That's why it's called sigma notation. Okay? This guy here, this left-hand side, is read as summation of xi. Okay, so summation of xi, I from 1 up to n. Okay, so summation of xi with I from 1 up to n. So it means you will just add all these xi's as you run your I from 1 up to n. So this is the definition. I equals 1, you have x1, plus I equals 2, you have x2, plus I equals 3, you have x3, plus until you have I equals n, so you have here plus xn. Okay? So this is your sigma notation. So for example, we have this 2 plus 3 plus negative 1 plus 5 plus 8 plus negative 3 plus 2. Okay? We can let x1 be equal to 2. So this guy here. X2 be equal to 3. This guy here. X3 be equal to negative 1. X4 be equal to 5. X5 be equal to 8. X6 equals negative 3. X7 equals 2. So here, okay, we can now rewrite this expression in sigma notation. Okay? So this expression here can be written as the sum of your xi, I from 1 up to 7. So this is the shorthand notation for this. Of course, that's if you know your xi's. So x1, x2 until x7. Okay? Questions? So for example, we have here the sum of 2i minus 3, I from 1 up to 4. So this guy here will be your xi. Most of the time, actually, the xi will be in terms of that subscript I. Okay? So this is your xi. So meaning, if we do this, this is your xi. Therefore, your x1, it's 2 times 1 minus 3. So 2 times 1 minus 3. Your x sub 2 will be 2 times 2 minus 3 because I now is equal to 2. X sub 3 will be 2 times 3 minus 3. And x sub 4 will be 2 times 4 minus 3. Okay? So this guy here, 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 and here, they all came from the formula 2i minus 3. Okay? And then, since you have expanded it this way, you can now calculate each. This guy here, 2 minus 3, that's negative 1. This here, 2 times 2, that's 4 minus 3, that's positive 1. Here we have positive 3. And then here we have positive 5. And then finally, you can just add this. And you will get positive 8. So this means this summation here, it's equal to positive 8. Okay? Questions? Now, here are some formulas for the sigma notation or for the summation. If you have any constant c, then you add the c to itself. So sum of c, I running from 1 up to n. So notice you don't have an I here. This means that you're just adding C. X equals 1. I equals 1, that's C. I equals 2, that's still C. Meaning, this guy here, this is actually your X sub I for all I. So X sub 1 equals C, X sub 2 equals C, X sub 3 is still C until you have X sub n equals C. Therefore, this guy here, you just have C plus C plus C plus C, and you have n of them. And therefore, if we simplify this is just C times n. Take note that n here it's fixed. I here is the one changing. It is the one running from 1 up to that value n. Okay? So summation of the constant, I from 1 up to n, it's just C times n. Now, suppose you have a constant C and you still have your X sub I. Okay? So this X sub I could be something that is in terms of I or not. Okay? So what's the formula for this? This guy here tells us that you have C times X sub 1 plus C times X sub 2 plus etc. plus until you have C times X sub n. Now you have C here, you have C here, you have C somewhere here, and you have C somewhere here. So C is a common factor. Okay? You can factor that C. And therefore, you will have C times X sub 1 plus X sub 2 plus X sub 3 until X sub n. But this guy here, X sub 1 plus X sub 2 until plus X sub n, you can write it as summation of xi, I from 1 up to n. Okay? So this guy here, this is this guy. And then, of course, this C here, it's this C here. So what does this mean? If you have a constant multiplier inside, okay, it's constant, it can go outside of your summation symbol. Okay? So summation of C times xi, I from 1 up to n, it's equal to C times the summation of xi, I from 1 up to n. So that constant can slide out. For this formula, suppose you have two expressions, both with I. So you have xi and then yi. Okay? So summation of xi plus yi, I from 1 up to n, this is the same as summation of xi, I from 1 up to n, plus summation of yi, I from 1 up to n. Meaning, it looks like this summation symbol can be distributed over the sum. Correct? So you can separate them like this guy here. Okay? And then, what if your xi is always I? Okay? What if your xi is always I? So meaning you have the sum of I running from 1 up to n. Okay? This means that you will have 1 plus 2 plus 3 plus until n. When I equals 1, you have this 1. Plus, when I equals 2, you have this 2. Plus, when I equals 3, you have the plus 3, etc. until plus n. So this guy here will be equal to this. N times n plus 1 divided by 2. So the sum of I from 1 up to n, it's equal to n times n plus 1 over 2. So this is a formula. Okay? So this guy here, and then this guy here. So that's a formula. Okay? What if your xi is equal to I squared? So meaning, you have sum of I squared, I from 1 up to n. So this means that you will have 1 squared plus 2 squared plus 3 squared until you have plus n squared. So if you added this, you will have this guy here. So another formula. Okay? So this guy here is equal to this guy here. N times n plus 1 times 2n plus 1 over 6. Okay? So, let's try to use these formulas. Okay? For example, here, this time, so earlier we have the sum of 2i minus 3, I running from 1 up to 4. Let us extend it. I running from 1 up to 15. Which means if you try to expand this, then you have a lot of things to write. And it's not really helpful in a sense that you will lose some time. So the formulas in here will really help you. Okay? So we have this sum of 2i minus 3, I from 1 up to 15. What we can do is to separate them. So you will see, you have sum of 2i, I from 1 up to 15, Because this is minus, of course, this is also minus here. Sum of 3I from 1 up to 15. Okay? And then, this is 2, this is constant, times I. So we can bring this constant out. That's why we have this line. So this guy here becomes 2 times the sum of I from 1 up to 15. And of course, this guy we just copied. So notice here, you have I from 1 up to 15. And in these formulas here, you have here I equals 1 up to n. So I equals 1 up to n. Take note of that. These formulas here, the two guys here, okay, as well as this guy here, okay, they will work only if your I starts from 1. If your I does not start from 1, then you have to adjust. Okay? So, this guy here, your I starts from 1. Okay? So, we can use the formula. So, for this guy, you have, of course, this 2 times this summation of I from 1 up to 15, it's 15 times 16 divided by 2. Okay? So, n times n plus 1 divided by 2. And then, for this guy here, you just multiply 3 times 15. Okay? So, it's this guy here. C times n. That's your end here. C times n. Okay? So, if we simplify this, we will have this guy. So, 2 times 2 divided by 2, they will just cancel. So, this guy will cancel this guy. So, 15 times 16, that's 240. And then 3 times 15, that's 45. And therefore, we'll just have 195. So, for this example, we have 195. Okay? Let's look at our next example here. So this time you have sum of quantity I minus 1 squared, I running from 1 up to 5. So in here you just have 5 summands or 5 terms. We call the thing inside here terms. Okay? So you only have 5 terms, you can just write them down. Okay? But for the sake of using our formulas, okay? For the sake of using our formulas, our solution here will be different from just enumerating the terms. So, sum I equals 1 up to 5. So, sum of I minus 1 quantity squared, I running from 1 up to 5. The first thing to do here is to expand this square thing. So, I minus 1 squared, that's I squared minus 2I plus 1. Correct? Then you can separate. So, sum of I squared, I from 1 up to 5, minus sum of I minus 2 times the sum of I from 1 up to 5, plus the sum of 1, I from 1 up to 5. And then if we use our formulas, we will have this guy here. So let me just recall the formula for I squared. So sum of I squared, I from 1 up to n, this is n times n plus 1 times 2n plus 1 divided by 6. So our n here, it's 5. So n, that's 5. N plus 1, that's 6. 2n plus 1. So 2 times 5, that's 10 plus 1, that's 11. And then, of course, you're over 6. And then you have here 2 times 5 times 6 over 2. So for the last time here, I'll have summation of I from 1 up to n. This is n times n plus 1 divided by 2. So n equals 5, n plus 1 equals 6. Then you have the divided by 2 here. And then here you just have 1 plus 1 plus 1 plus 1 plus 1 plus 1. Or how many was that? Should be 5 times 1. Okay, that's why you have the plus 5 here. And therefore, if we simplify this, we will have this 55. Notice 6 over 6, they will cancel. So you'll just have 5 times 11. And then here 2 over 2 will cancel. So you have 5 times 6, that's your 30 here. And then you have the 5. And therefore, you will get 30. Okay? Questions? Now, what if we replace 5 by n? So you have summation of I minus 1 quantity squared, I running from 1 up to n, where n here, it's any positive integer. Well, we'll just use similar solution as in before, and then we'll just apply our formula. So first, we can expand this into this one. So summation I from 1 up to n of I squared minus 2i plus 1. Then we separate. And then these two here, we can bring it out. That's why you have this guy here. And then we use the formula. So n times n plus 1 times 2n plus 1 over 6 minus 2 times n times n plus 1. Then here plus n. Okay? So if we simplify further, we will have this expression. 2n cubed minus 3n squared plus n over 6. Okay? Questions?